PreAP, PreCalculus. This is note section 3.1, factoring cubic, quartic, and quintic polynomials. At this point, you should have already reviewed from the previous videos for this same section how to factor a polynomial that has 4 terms, 3 terms, and 2 terms. So now we're just putting it into practice here. Factor each of the following polynomial functions whose equations and graphs are provided. So we are supposed to factor. Then set each factor equal to 0 and find the values of x. So set each factor equal to 0 and then find each factor. So there's 3 things we're supposed to do. Factor, set, and find. So if we are supposed to factor this and set it equal to 0, that means we're finding the zeros of the function, the x-intercepts, the solutions. So we set it equal to 0. When we factor it, we are trying to, first of all, we want to make sure the terms are in descending order with respect to the exponents, from biggest to smallest, which they are. We want to factor out the greatest common factor. Each of these terms we can divide evenly by 3x, leaving us with x squared plus 4x plus 4. Now, when you have a trinomial, which we have, there are 3 terms, you want to check to see if it's a perfect square trinomial. Is this a perfect square trinomial? Well, let's see. If we break this x squared apart evenly, so that it's a square that's x by x, and we take this 4 and we break it apart evenly, so it's a square. That's not a square. So if it's this area is x squared, this area is 4. If it's a square and its area is 4, then each dimension is going to be 2. So that means if this is actually a perfect square, that this rectangle here would have dimensions x by 2. So that would make this 2x. And this rectangle here similarly has dimensions 2 by x, which makes this 2x. So I got all of this from just this first term and last term. What I'm trying to figure out, is this middle term 4x the same as these 2 rectangles together? 2x and 2x is 4x. So yeah, this is a perfect square trinomial. So how does it factor? Well, it factors into this big square. This big square has dimensions x plus 2 times x plus 2. Or in other words, x plus 2 quantity squared. Factor each of the polynomials. Then set each factor equal to 0. So let's set each factor equal to 0. So 3x equal to 0, x plus 2 equal to 0, x plus 2 equal to 0. If you solve each of these, you get x is 0, x is negative 2, and x is negative 2. Doesn't matter that you set this factor equal to 0 twice. It actually does, and we'll get into that at some point, because special things happen when you have the same factor more than once. I'll just tell you, if the same factor is a factor an even amount of times, it means that that x-intercept is tangent to the x-axis. If a factor is a factor an odd amount of times, then that solution goes through the x-axis. Set each factor equal to 0 and find the values of x. We did it, set equal to 0, we found the values of x. There's 2 more questions here. What's the y-intercept of this graph? Where does it cross the y-axis? It looks like it's crossing at 0. What is the constant term in the equation? Well, here is our equation. There doesn't appear to be a constant term, so that really means this constant term is plus 0. So we could say there is no constant term, or you could say it's 0. Next one. gx is x squared minus 5x squared plus 4. This is not a perfect square trinomial. Because if you break this apart into x squared and x squared, and you break this apart into 2 and 2, which they're both perfect squares, the rectangle that you're going to have up in this corner is going to be 2 times x squared, which is 2x squared. And so is this rectangle here. 2x squared and 2x squared is not this 5x squared. So this is not a perfect square trinomial. So then we just try to see, can we break this into two binomials? The lead coefficient's 1, which it is, excuse me. It's the easy type to factor. We need two numbers that multiply to get 4 and add to get negative 5. That would be a minus 4, and we have an x squared minus 1. Is this a difference of two squares? To be difference of two squares, this has to be a perfect square, which it is. This has to be a perfect square, which it is. This has to be a difference. Yes to all those. So it factors into x minus 2 and an x plus 2. The x comes from square rooting the x squared. That's the first position of each of these. The 2's come from the square root of 4. That's the second position in each of these. And if this is a subtract, which it is, makes one of these plus and one of these minus, doesn't matter which is which. This is also the difference of two squares. X squared is a perfect square, 1's a perfect square, and it's a difference. So it factors into an x minus 1 and an x plus 1. We set each factor equal to 0, because the directions told us to. We are expecting then this to cross the x-axis 4 times. Not sure why I write the x on the right for those, but I did. So let's check it out. 2 is a factor once, it crosses. Negative 2 is a factor, I said that wrong. X minus 2 is a factor. 2 is a solution once, it's tangent at 2. Pardon me, it crosses at 2. I am totally misspeaking. Negative 2 is a solution once, it crosses at negative 2. 1 and negative 1 are solutions an odd number of times once, it crosses. What's the y-intercept of this graph? Well, it crosses here at 4, it appears. What's the constant term in the equation? That constant term is 4. Coincidence? Doubt it. On the previous problem, the y-intercept was 0, and the constant term, there wasn't one, which means the constant term was 0. Here it crosses at 4, the constant's 4. Coincidence? I don't think so. All right, next one. This is 4 terms. GCF here is 1, so we don't do that. Set this equal to 0. We are going to factor by grouping. I'm going to group the first two terms together and the last two. GCF of the first two terms is x squared, leaving me with 2x plus 5. GCF of the second group is a minus 1, leaving me with 2x plus 5. This is one term, this is one term. Both of those terms have in common a GCF of 2x minus 5. If we factor the 2x, I might have said minus, it's plus 5. If we factor the 2x plus 5 out to the front, we are left with an x squared minus 1. Now once you factor, you want to be able to see, can you factor more? 2x plus 5 doesn't factor more, there's no GCF here, and there's no exponent. X squared minus 1 is a difference of two squares. It factors into an x minus 1 and an x plus 1. So we have 3 unique factors. So we would expect to have 3 unique x-intercepts. Set each factor equal to 0. And we solve each of these little fellas. So we are thinking, if we look at this graph over here on the right, we're going to have x-intercepts of negative 2.5, which is negative 5 over 2, negative 1, and positive 1. These are solutions one time, an odd number, and in each case, it's crossing the x-axis. What's the y-intercept of this graph? It looks like it's a negative 5. What's the constant term? It is definitely a negative 5. Not a coincidence. One more of the same type of problem. This is a trinomial, 3 terms. There is a GCF here of 1 only, so we don't worry about that. This is not a perfect square trinomial because this first term is not a perfect square, and this is not a perfect square. Leading coefficient is not 1, so this is the hardest type to factor. We have to split this middle term and then factor by grouping. Here's how this works. Bring the first term down, bring the last term down. This middle term is going to get split into 2 separate terms. To determine how it splits, we're going to use an acronym, MAN. M stands for what we're multiplying together. Multiply the first and last term together, that is 6x to the 4th. We're trying to find 2 terms here that multiply to get 6x to the 4th. We want to be able to add those same 2 terms to get this middle term of a negative 5x squared. I think that you'll find that these terms would be negative 6x squared and a positive 1x squared. If I multiply these, I get negative, that's not right. If I add those, that works out. If I multiply them, it does not. Let's say negative 3x squared and a negative 2x squared. If I multiply those, I get positive 6x to the 4th. That works. If I add those, I get negative 5x squared. All right, that works. So this is going to be a minus 3x squared and a minus 2x squared. The order in which you write those 2 middle terms does not matter. Once you've split the middle term, then you factor by grouping. What's the GCF of the first group? Once again, we're setting this equal to 0. I could have done it in this step here, but I just didn't think of it. GCF of the first group is x squared, leaving us with 2x squared minus 3. GCF of this next group is a negative 1, leaving us with 2x squared minus 3. Now you might look at this and think, well, how do you know it's a negative 1? Why couldn't it just be 1? It could be 1, but we want the signs of this to be identical to the signs of this. And in order for that to happen, because right now they're the opposite signs, we need to factor a negative 1 out. Each of these terms has the same factor of 2x squared minus 3. I'm going to set each factor equal to 0. Well, let me rephrase that. This doesn't factor anymore. This does. This is the difference of 2 squares. It's an x minus 1 and an x plus 1. Set each factor equal to 0. The reason that we're setting the factors equal to 0 is we're saying that the y value is equal to 0 on the x-axis. We're trying to find the x-intercepts. We got an irrational x-intercept of negative square root of 3 over 2 and positive square root of 3 over 2. And we have 2 rational x-intercepts of negative 1 and positive 1. What's the y-intercept of this graph? Looks like it's 3. What's the constant in this graph? That is definitely a 3. That is not a coincidence. To sum up, what connections do you see between the equation of a polynomial and the graph of the function? So let's write some stuff down. 1, the constant term of the polynomial is the y-intercept of the graph. We have found that in every case, those are not coincidences. 2, the degree of the function determines the maximum number of real zeros of the graph. I will show you what that means here in a moment. The degree of the function determines the maximum number of real zeros, because we could end up with some imaginary ones, and those do not show up on the graph. Third point, when the factors are set equal to 0 and solved, the results of this are the zeros of the graph. To show you each of these once again, like in this last one, P of x. The constant term is the y-intercept. Constant term was 3, the y-intercept is 3. Not a coincidence. The degree of the polynomial, the degree of the function, which is the biggest exponent, that's a 4, determines the maximum number of real zeros. So this was 4, so at most there could be 4 x-intercepts. There were. When factors set equal to 0, and here's our factors set equal to 0, and solved, here's our solutions. The results are the zeros of the graph. X-intercepts, x-intercepts, x-intercepts. Please do 3.1 homework.